Australians all love the beach. When the weather's right, there is just nothing like baking in the sun, having a swim, or just overlooking the expanse of the ocean, listening to the sounds of crashing waves against the shore. Coastlines also play a more important role. They connect larger habitat areas and are vital for local ecosystem survival. They also serve as important tourist corridors, promoting local economies. Within Victoria, Australia, coastal erosion has posed a significant threat to these crucial locations, and although funding and solutions have been proposed, realistically, these are just short-term answers for this monumental crisis the coastal regions are preparing for. Erosion has always been a significant issue for the Victorian coastline. However, recent weather events have severely affected areas of the Victoria coast. This initiated a request to assess Victoria's coastal reserves by the Victorian Environmental Assessment Council, or VEAC. Climate change, sea level rise, and increasing extreme weather events were all major focuses of the VEAC final report, with conservative estimates of a 20 centimetre sea level rise affecting more than 75% of coastal reserve land units. The most serious risk posed to the coastal environment is the damage to ecosystems and loss of habitat from contamination, erosion, and inundation. These crucial coastal reserves typically span less than 100 metres, yet make up around 25% of the coastline. This makes them extremely sensitive to any habitat loss. Communities are also expected to be affected, with the coastal town of Inverloch already experiencing its foreshore recede by 33 metres. The Victorian State Government has spent $60 million on marine and coastal projects since 2014, and a further $10 million on the Port Phillip Bay Fund that's designed specifically to support projects that protect and enhance the environmental health of Port Phillip Bay. Monitoring and forecasting coastal erosion are both invaluable tools which would provide vital information on the current state of coastal regions. This knowledge would allow a targeted, strategic approach to defending Victoria's coasts. The low cost and field time of unmanned aerial vehicles or drones makes them extremely appealing for this kind of application.
The scope of the project was initially going to include a more substantial amount of the Victorian coastline. However, due to the pandemic, focus was instead shifted 113 kilometres southwest of Melbourne, in the surrounding area of Anglesey. Overall, 3 coastal areas were focused. Anglesey Main Beach, a built-up rocky cliff face predominantly spanning the entire coastline along the main town. Point Road Night, a narrow ridge which protects Anglesey Main Beach from the Southern Ocean, consisting of a large open sand bay. Urquhart's Bluff, situated near Ailey's Inlet, is a stretch of coastline with eroding bluffs, limestone cliffs, and rugged reefs.
Once we had completed our research and identified our initial project scope, we had to plan and test our methodology. The basic methodology process was to first collect on-site data, to then process that data, and finally construct a 3D model that we could then analyse. Our project timeline and methodology was as follows. Between April and May, we undertook site planning and industry collaboration as we reviewed the current state of knowledge regarding coastal erosion and monitoring, including the utilisation of drones for these purposes. We engaged with stakeholders including councils and coast management authorities about the problem and project. We developed an appropriate methodology for the project and then identified suitable regions for implementation of this methodology. In May, we conducted our preliminary site investigations. This entailed a single-day road trip to the selected sites as well as site reconnaissance and planning. Preliminary data was collected via handheld imagery capturing as well as drone imagery capturing. We reviewed the data and methodology and assessed for potential improvements and the feasibility of alternate designs. Between June and July, we conducted our secondary site investigation. This involved capturing drone footage and imagery at Urquhart's Bluff. We then reviewed the data and methodology, assessing for potential improvements and the feasibility of alternate designs. Between June and September, we submitted our progress report. We also conducted our post-processing and lab work by digitizing our initial footage and imagery. We then constructed 3D models for the individual sites and then reviewed these results, assessing potential improvements and feasibility of alternate designs. In October, we drafted our final report and conducted an analysis of the 3D models that had been constructed. Then, between October to the current date, we finalized the report and created our presentation.
Because we were using the photogrammetry process, it required us to digitize our video footage, so video editing software was used. We used Sony Vegas to adjust the frame rate and render individual frames as JPEG files. These frames were then imported into Autodesk's Recap Photo and then uploaded to their service where it was processed and compiled into a 3D model. After numerous failed attempts, we were finally able to attain detailed 3D models of each site location, which could then be analyzed and cross-compared.
Overall, despite the disparities of the 3D mesh and textured models, the reconstruction is very similar for all 3D models. Considering the noticeable differences between different flight paths taken to capture the footage along the 3 studied areas, 3 main factors were identified to have had a likely influence on the overall 3D constructions. The overlapping of images depends on the spatial coverage of the photographs, along with the angle on which the drone gimbal has been set to. Another factor which has been identified to have also caused differences in image quality and resolution are gaps in image triangulation. This spatial resolution is an often heavy influence on the distance between the drone camera gimbal and the point of reference being the cliff face and sand. Also, variations of cloud coverage which directly corresponds to the illumination of the cliff and face and sand location. Levels of low light tend to make detection harder for videography and photogrammetry. For the 3D mesh and textured model of Point Road Night, it can be assumed that the quality of picture and model would be more effective for higher luminosity for both the rock and sand at the site location. Urquhart's Bluff was photographed on both the 5th of May and the 14th of July 2021. From these images, we created 2 separate 3D models. These are then scaled and compared. A comparison range of 1000mm and a tolerance of 100mm were selected. Both these models experienced some variation which was to be expected, as the surrounding floor area of the images differed, this due to being outside of the comparison range. In certain areas, slight variations were caused by a difference in the mesh resolution between both the May and July models. This difference is especially apparent in the alcove of the cliff face, which has been highlighted in purple. Excluding these outliers, the models did not differ greatly in comparison, as the region did not undergo any significant changes in this short time frame.
The ability to forecast erosion depends greatly on the accuracy of the data gathered. The drone used in our project possessed a 12 megapixel camera. However, in other studies it was seen that cameras of far higher quality were utilised to provide more accurate and precise results and data. These extra details would enhance the ability to detect and thus forecast potential erosion, as smaller changes in the data can be seen between the various images taken over time.
In this study, the imagery taken from each beach and coastal front during UAV longshore surveys have shown similar results. It is evident that there is coastal erosion and sand sediments of similar aspects along all 3 areas. There are key knowledge gaps surrounding the forecasting of the project. This is important to note as it is the next key part of the study. This will prove challenging with the current small pool of data to draw on. There is also very little literature surrounding the applications of drone technologies in Australia specifically, and this is an area that can be further explored by the study. The areas that require improvement are to gather more quality data, as well as to engage with more stakeholders to speed up this process, and to increase the information at hand to be able to compare erosion across various conditions and at even more locations. We decided that coastal erosion is an ongoing issue predominantly around areas of the Victorian coast. Using drones to contribute to monitoring key locations and justifying changes in our shorelines will hopefully result in local councils to take more action and shed much more needed attention our coastlines deserve.